Have you ever been completely stuck on a problem? I mean, one of those problems where every single solution you think of just creates a whole new set of issues? Well, what if I told you there's a repeatable, step-by-step algorithm designed specifically to crack those impossible problems? Today, we're going to unpack one of the most powerful tools for systematic invention ever made.
Okay, to really get what I'm talking about, let's start with a classic puzzle. Think about a window. Its whole job is to be transparent, right? To let in light. But you also want privacy, which means you need it to be opaque. So, how can a window be both transparent and opaque at the exact same time? It feels like a total paradox, a logical impossibility. This is what engineers and inventors call a physical contradiction. It's when one single thing has to have two opposite properties. And I'm not talking about a simple trade-off, like making something stronger but heavier. No, this is a real paradox, transparent and opaque, hot and cold, long and short. The whole point of true invention isn't to find some lazy compromise in the middle. It's to completely obliterate the contradiction.
Now, here's the wild part. The way you solve this isn't by sitting around waiting for a flash of genius. It's a rigorous, data-driven process. A Soviet engineer named Genrich Altshuller and his team literally analyzed over 1.5 million patents. And what they found was that true breakthroughs weren't random. They followed predictable patterns. He took those patterns and created a whole system called TRIZ, which is the theory of inventive problem solving. So here's our game plan. We're going to dive into the most powerful tool in the entire TRIZ toolbox, ARIZ. I'm going to walk you through it step by step. First, we'll see how to define the problem with surgical precision. Then, we'll look at how to systematically generate solutions. And finally, how to refine those ideas until they're bulletproof. Let's get to it. So you can think of TRIZ as this giant theory of invention. ARIZ, on the other hand, is its most advanced weapon. It's not just another tool in the box, it's the guided missile you use for your toughest, most tangled-up challenges. And this really breaks down the difference. See, TRIZ is like a massive library full of inventive principles and cool techniques. You can wander in and pick a book off the shelf. But ARZ, that stands for the Algorithm for Inventive Problem Solving, is the expert librarian who gives you a guided tour. It's a structured 9-step process that tells you exactly which tool to use and when, so you get the most out of the entire library. For our window problem, we don't want to just browse, we want to launch that guided missile. All right, let's get into the algorithm. Part 1 is all about defining the problem. And honestly, this is the most critical part. ARIZ forces you to be incredibly precise right here, because if you frame the problem perfectly, the solution almost starts to find itself. The first 3 steps are designed to force that clarity. So for your problem, step 1 is to state the mini-problem. Keep it simple, no jargon. For our window, it's just, the window needs to let us see out, but doing so destroys our privacy. Easy. Then, step 2, you have to identify the conflict zone. Where exactly is this fight happening? For us, it's the pane of glass itself. That one object is where transparency and opacity are at war. Now hold on for step 3, because this is where the magic really starts. Okay, step 3 is where you define the ideal final result, or the IFR. The IFR is the perfect, almost fantasy-level outcome. So for our window, the IFR isn't about better blinds or curtains. No. The ideal result is the glass itself changes from transparent to opaque whenever we want, using no extra parts, no cost, and no energy. This forces you to aim incredibly high, and it perfectly crystallizes that physical contradiction. The glass must be transparent, and the glass must be opaque. So now that we've framed the problem perfectly, let's move into part 2. This is where ARIZ builds a bridge from that deep analysis to actual breakthrough ideas. It's where we tap into the collective knowledge of millions of past inventions. And listen, this is not brainstorming, this is a systematic search party. Step 4 tells you to mobilize your resources. That means you have to list every single thing you already have in the system. Substances? We've got glass, air. Fields? Well, there's light, maybe some electricity in the wall, heat from the sun. You use what's already there. Only after you've done that, in step 5, do you bring in the heavy artillery, the TRIZ knowledge base of inventive principles, which you apply directly to that contradiction we identified earlier. ARIZ even has these cool little mind games built in to get you thinking differently. My favorite is the smart little people model. You literally imagine a team of tiny, intelligent workers living inside the pane of glass. What instructions would you give them? How could they make the glass transparent one second and opaque the next? Maybe you tell them to rearrange the molecules on command? It sounds a little silly, but it's a fantastic way to visualize solutions on a micro level. In that line of thinking,
When you combine it with the principles from the TRIZ knowledge base, it leads you straight to a super powerful idea: separation in time. If something can't be transparent and opaque at the same time, then don't make it do that. Just have it be those things at different times. The glass is transparent now when you want a view, and it's opaque later when you want privacy. The contradiction is totally resolved by breaking that at the same time constraint.
So, we have our core concept, but ARIZ is way too rigorous to stop there. The final phase is all about taking that clever idea and making it practical, robust, and elegant. It's about making it bulletproof. These last steps are your quality control. Think of step 6 as your emergency exit. If you're stuck, the algorithm tells you to go back and rephrase the problem from a totally new angle. Step 7 is the honest-to-goodness reality check. How close did you get to that magical, ideal final result? Then step 8 is where you actively try to break your own idea. You have to anticipate what could go wrong. Does it use too much power? Will it last for 20 years? Finally, step 9 forces you to write down how you got there. This way, you're not just solving one problem, you're becoming a better inventor for every problem after this. So, what's the big payoff for all this structure? Well, by following the algorithm, defining the contradiction, using existing resources like electricity, and applying the separation in time principle, we logically arrive at a real-world invention: electrochromic smart glass. It's a material that, with a tiny electrical pulse, literally rearranges its molecular structure to become transparent or opaque on command. It's the ideal final result made real.
You see, the real power of ARIZ isn't just about solving one specific problem. It's about completely rewiring your brain to approach all complex problems in a new way. It gives you a new mental algorithm for innovation.
So, what do you need to walk away with? First, stop settling for compromises. Hunt down the core contradiction and figure out how to resolve it completely. Always start by defining that ideal final result. It sets an incredibly high bar that pushes you toward breakthrough. Be systematic. Analyze the problem, the conflict zone, and your resources like a detective. And never forget the core strategies. If you can't have opposite things at the same time, separate them, in space, in time, or under different conditions. This is how you make invention a skill, not just luck.
ARIZ basically turns invention from a mysterious art into a repeatable science. It proves that even the most tangled, paradoxical problems have a logical path to a solution. You just need the right algorithm to find it. So I'll leave you with this question: what's your impossible problem, and how are you going to use these steps to finally solve it?